Hello, today we are going to solve a problem in wave equation. We all studied the derivation of wave equation and the solution of wave equation, how to solve a wave equation that we studied earlier. Now I am going to a problem. Look at this problem. A tightly stretched string with fixed endpoints x equal to 0 and x equal to L is initially in a position given by y is equal to y0 sine cube pi x by L, where 0 less than or equal to x less than or equal to L. If it is released from rest from this position, find the displacement function y of xt. So first of all, we have to write, for solving this type of problems, we have to write the wave equation. We all know what is wave equation. What is wave equation? Okay, wave equation is, we have wave equation is, what is wave equation? Dou square u by dou t square is equal to a square into dou square u by dou x square. This is wave equation. So now we are given, we have to write the boundary conditions and initial conditions. Then only we have to write the solution. Okay. Now from this question, we have to read carefully this question and find out what are the boundary conditions and what are the initial conditions that are given in this question. Okay, look at this. The string is tightly stretched string with fixed endpoints. From this point, we have to write the boundary condition. That is, we have to identify that the boundary conditions are given as 0. Fixed endpoints means both the boundary conditions are 0. So what are the boundary condition? Y of given this displacement function is y of xt. So boundary conditions, we know what are boundary conditions. Boundary conditions are y of 0t and y of lt. Those are the boundary conditions. So I am writing here boundary conditions are y of 0t is equal to y of lt is equal to 0. That we get from this point. Fixed endpoints means boundary conditions are 0. Okay. Now we have to write the initial conditions. Two initial conditions are there. Which are they? First one, initial displacement, and second one, initial velocity. So look at this. Given the string is initially in a position given by y is equal to y0 sine cube pi x by L. That is initial position. Initial position means initial deflection or initial displacement is given. So what is the notation for initial displacement? Initial displacement is y of x0. That is the initial displacement and we denote it as f of x. So given initial conditions are y of x0 is equal to f of x and equal to y0 sine cube pi x by L. So this is the initial displacement or initial deflection. Now the another initial condition is initial velocity. What is the initial velocity? That also we have to find out from this question. Look at this. If it is released from rest, we know that when a string is released from rest, its initial velocity is 0. Initial velocity will be 0 if it is released from rest. From that point, we can write the initial velocity, that is dou u by dou t at t is equal to 0 is equal to g of x, and that g of x will be 0 since it is released from rest. So initial velocity dou u by dou t at t is equal to 0 is equal to g of x, and this is equal to 0. So we write all the four conditions. So we have to find out the four conditions from the question which are hidden in the question. Okay. So we write dou y of 0t equal to y of lt is equal to 0, which are the boundary conditions, and the initial conditions are f of x is equal to y0 sine cube pi x by L, and initial velocity dou u by dou t at t is equal to 0, which is equal to g of x, and this is equal to 0. Now we are going to write the solution of this wave equation. the most general solution, this is equation number 1. Solution of equation 1 is, we know that the solution is y of xt is equal to sigma n equal to 1 to infinity an sin n pi by l x into cos n pi a by l t plus bn sin n pi by l x into sin n pi a by l t. So this is the solution of the wave equation. Okay, but here g of x is equal to 0. Since g of x is equal to 0, we know that if g of x equal to 0, bn is equal to 0. The coefficient bn is equal to 0. When g of x equal to 0, bn equal to 0. That we know. So I am writing, since g of x is equal to 0, we have bn is equal to 0. Okay, therefore this solution reduces to be, this solution becomes, therefore we have y of xt is equal to sigma n equal to 1 to infinity an into sin n pi by l x into cos n pi a by l t. So this is the solution of this given question. Okay, now we have to find out what is a and we have to find out the coefficient. For this we have to apply this condition, that is when t is equal to 0, f of x equal to y0 sin cube pi x by l. Since we are given initial condition, that is initial displacement as a trigonometric function, if the trigonometric function is given, we have to find out the coefficient by comparing. By comparing both sides, comparing the coefficient, or by comparison we should find out the coefficient of this solution. If trigonometric functions are given, that you have to keep in mind. So here we are given trigonometric function, so I am going to compare the coefficient. So for that I am putting this condition in this equation. So given y of x0 is equal to y0 sin cube pi x by l. Now putting this condition in this equation number 2, we get when t is equal to 0, here y of xt becomes y of x0. I am putting t is equal to 0 in this equation, therefore we get y of x0. Y of x0 is y0 sin cube pi x by l. Therefore equation 2 becomes y0 sin cube pi x by l is equal to, here it is sigma n equal to 1 to infinity a n into sin n pi by l x into, this becomes cos 0. Since t is equal to 0, this term becomes cos 0. The value of cos 0 is 1. So the equation reduces to into this form. Okay, now I am expanding this sigma, that is I am putting n equal to 1, 2, 3, etc. Therefore y0 sin cube pi x by l is equal to, when n equal to 1, we get a1 sin pi x by l, since n is equal to 1, plus now I am putting n equal to 2, so a2 sin 2 pi x by l, plus next term is a3 sin 3 pi x by l, plus etc. Okay, now what is sin cube pi x by l? We all know that. Look at this. We know that. What is sin 3 theta? We know that sin 3 theta equal to 3 sin theta minus 4 sin cube theta. This we all know. This is a trigonometric relation or trigonometric formula. From this formula, I am writing sin cube theta. What is sin cube theta? Sin cube theta is 3 sin theta minus this term goes to right hand side, sin 3 theta divided by 4. Okay, is it right? Yes, sin cube theta equal to 3 sin theta minus sin 3 theta by 4. But here theta, in the place of theta, here it is pi x by L. So replacing pi x by L, we can write this as pi 0 into sin cube pi x by L, 3 sin pi x by L, 3 sin pi x by L minus sin 3 pi x by L, the whole divided by 4, okay, is equal to, now I am writing these terms in the RHS, okay, this is equal to a1 sin pi x by L plus a2 sin 2 pi x by L plus a3 sin 3 pi x by L plus etc. Now look at this comparing, we can compare the coefficients. Here a1 is the coefficient of sin pi x by L. What is the coefficient of sin pi x by L here? Look at this sin pi x by L. The coefficient is 3y0 by 4. So a1 equal to 3y0 by 4. I am writing this here. Therefore a1 is equal to 3y0 by 4. What is a2? a2 is the coefficient of sin 2 pi x by L. Look at this, here there is no term in sin 2 pi x by L. Therefore what will be a2? a2 is 0. a2 equal to 0. What is a3? a3 is the coefficient of sin 3 pi x by L. Here sin 3 pi x by L is present. So the coefficient of sin 3 pi x by L is minus y0 divided by 4. So this is minus y0 divided by 4. Now what is a4? a4 equal to, a5 equal to, etc. is equal to 0. Okay. Therefore only two coefficients are present, a1 and a3. Therefore the equation, we have to substitute this in equation number 2. Therefore equation 2 becomes y of xt is equal to, not sigma, first term is, I am giving n equal to 1, 2, 3. So first term is a1 is 3y0 by 4. 3y0 by 4 into, this becomes sin pi x by L, since n is equal to 1, sin pi x by L cos pi at by L. Okay. Next term n equal to 2, a2, but a2 is equal to 0. So there is no second term. Now the third term, n equal to 3, we have a3 is equal to minus y0 by 4. So I am writing minus y0 by 4 into sin, this n becomes 3 pi x by L into cos 3 pi at by L. All the other terms are 0. So this is the final solution of the given question. So this is the method of solving wave equation. First we write the wave equation, then we write the boundary conditions and initial condition, and identifying which initial condition is 0, we write the solution of wave equation and then find out the Fourier coefficient. So this is the procedure for solving wave equation. Okay, thank you.